In this video, I'm going to show you the technique that I use to solve almost all probability questions. And it might seem very simple, but it's highly effective. I'm also going to show you the two most common mistakes that I've seen students for many years make on probability questions. And if there's one thing I can achieve from this video, it's to convince every single person watching to never make these two mistakes. So let's get straight to an example. What am I talking about? Imagine there was a question where it said that there are 3 red beads and 5 green beads in a bag. 2 beads are selected from the bag without replacement at random. What is the probability of getting 2 green beads? How would you do this? Let me first introduce my technique. I call it the letter technique, which is not very imaginative because it just involves using letters. But anyway, the technique involves writing down what we need in the form of letters. In this question, we need 2 green beads. That's what the question is asking for both of the beads to be green. We can use G to represent getting a green bead. So getting 2 green beads would be a G and then a G. Seems obvious, right? Seems useless, but we'll see in future examples how important that technique is. But anyway, what's the most common mistake? Well, can I just ask you, we have 3 red beads and 5 green beads. What's the probability of getting a green bead on your first selection? That's right. Don't consider both selections all in one go. Can you just tell me the probability of getting a green bead on your first selection? Hopefully you said 5 out of 8. There are 5 green beads and there are 8 beads in total. So the probability on your first selection of getting a green bead is 5 out of 8. I don't want you to consider the whole scenario in one go of picking 2 beads at once. I want you to think of it as picking 1 bead and then the next bead, and we will get the right answer. Okay, so we have a 5 out of 8 chance of our first bead being green. What about that next G? What about that next bead being green? Here's the most common mistake that I see in probability. People think it's 5 out of 8 again. The problem is we've already picked a green bead out. So there's only 7 beads left in the bag. And how many of those beads left in the bag are green? 4. Because the first bead was green, there's now only 4 green beads left. So for that second G, for the getting green again the second time, we have a 4 out of 7 chance of getting a green bead, not 5 out of 8. There are only 4 greens left after we've taken the first one out and 7 beads in total. Some people remember one bit and forget the other bit. They might remember the number of green beads has gone down to 4, but they think the total is still 8. No, the total is down to 7. So it's 4 out of 7. The probability of getting the first green bead was 5 out of 8, but getting the second green bead was 4 out of 7. Getting the first one changed the probability of getting the second one. Now, what do we do with those two numbers? I touched on this in another video, but whenever the word and is involved, we multiply. Whenever the word or is involved, we add. Now, do we want a green or green and a green? We want a green and then another green. So we do 5 out of 8 multiplied by 4 out of 7. The and means multiply. You could simplify those fractions or multiply them straight away to get 20 over 56, which simplifies down to 10 over 28 or 5 over 14, which is our correct answer. 5 over 14 is the probability of us getting 2 green beads from our bag. So far you're thinking, okay, that makes sense. That's really good, Philip, but that letter technique wasn't really useful. When is it useful? The next 2 examples will show more and more why it's essential, especially the last example. Okay, so what's our second example? Imagine we have the same scenario with the 5 green beads and the 3 red beads, except this time the question was, what is the probability of picking 2 beads of the same color? Now, with letters, can you write out the 2 scenarios in which we end up with 2 beads of the same color? Hopefully you got R and R, standing for red and then red, or G and G, standing for green and then green. Let's work out those 2 scenarios. First, R and R. Can you tell me the probability of getting red and then red? The first red would be 3 out of 8, and the second red would be 2 out of 7, as we saw earlier. 3 out of 8 times 2 over 7 is of course 6 over 56. But this time I don't want you to simplify. In the harder probability questions, save the simplifying until the very end, and you'll see why in a moment. Now, we don't need to work out the probability of getting a green and then a green because we already did it with our previous question. It was 20 over 56, which we simplified, but we're not going to simplify it here. 20 over 56. Now here's the key question. Do we add those 2 together, the red and red, green and green, or do we multiply them? Do we add the 6 over 56 to the 20 over 56, or do we multiply? Well, we want a red and a red or a green and a green. You can't have a red and a red and a green and a green because that'd be picking 4 beads. We're just picking 2. It's red and red or green and green. 2 beads of the same color red or 2 beads of the same color green. It's an or, so we add. And that explains why we don't simplify, because now we have a simple addition to do. 6 over 56 plus 20 over 56, which gives us 26 over 56. And only now, at the last stage, do we simplify. 26 over 56 divides by 2 to get 13 over 28, which is our correct answer for this second question. I know what you're thinking, we still haven't gotten to the second most common mistake, but that's going to come up in this, our third and final example. Imagine again we have the same scenario, except this time the question was, we're picking 2 beads at random and without replacement. What is the probability that the 2 beads we pick have different colors? This example ties in everything I've been talking about. Most students at this point would say something like 5 out of 8 times 3 out of 7. They'd say, look, there's 2 beads of different colors, a green bead and then a red bead. And they would show off and say, look, I remembered that the total number of beads goes down to 7. But that answer would be wrong. Why is it? Well, one reason I can give is they didn't use the letter technique. With letters, can you show me how to get 2 beads of different colors? Hopefully you wrote down G and then R, and you wrote down R and then G. And that's why I recommend using letters. It's much more obvious that we have to consider both scenarios. G then R, R then G. If we just focused on G then R, which is 5 over 8 times 3 over 7, we're working out the probability of specifically getting a green first and then a red. But that's too narrow and too specific. It could have also been a red and then a green, and we have to account for that fact. Using letters reminds us to account for all the different orders in which the question could get the desired result. And that was the second most common mistake in all of probability, neglecting the different orders in which things can happen. Just considering G then R and not considering R then G. We have to consider both to get the right answer. Let's work out G and then R. That's 5 out of 8 times 3 out of 7. The second fraction is 3 out of 7 because after we've picked the green bead the first time, there are still 3 red beads, except there are only 7 beads in total. That multiplies to get 15 over 56, which again, we do not simplify until the very end. What about getting a red and then a green? Can you work that one out for me? You can even pause the video and try and work out the whole rest of the question if you like. A red and then a green would be 3 over 8 times 5 over 7, which gets us 15 over 56. Do we multiply those probabilities or do we add them? It's a green and then a red, or a red and then a green. So we add 15 over 56 to 15 over 56, giving us 30 over 56, which we can simplify down to 15 over 28 and no further. We have our final answer of 15 over 28 for the probability of picking two beads of different colours. And that demonstrated how to avoid the second most common mistake in all of probability, neglecting to consider the different orders involved. So now, in one short video, you've seen the two most common mistakes in all of probability. Not adjusting for when you've already taken out a certain bead and reducing the total and the numerator, and two, neglecting the different orders. You've also seen how I use letters to represent possibilities to make my calculations easier and clearer. Now, of course, this video doesn't cover all of advanced probability, but the bulk of the simpler questions you'll get on the GRE, GMAT, and even loads of other school exams involving probability are covered by this simple technique. So if you like the video at all, please do leave a like, leave a question, leave a comment. I read them all, and thank you for watching.